Hello, everyone. Hello. Welcome to the Wednesday webinar from Contact Live. Today, we've got why knowledge graphs are important for scholarly publishing, and that's going to be presented by Dindo, who's the Chief Data Scientist of Yewno. This is our 12th weekly webinar, and we're very excited to have Yewno talking about this very, very, very important topic. My name's Clive Snell. I'm the MD of Contact Live. We're now looking back on 3 months of these during the lockdown and as things start to ease up, but we will continue after a short break fairly soon in the summer with more regular webinars. We're very excited about bringing people together and making sure everyone is well. We're using Zoom webinar for this. Your mics are muted, but we would encourage you to file questions using the Q&A button. Harris is somewhat shy. He's not going to show his face, but he is going to show his presentation. I will pick up with you guys at the end. We're hoping to run 25 minutes of pres and about 5 minutes of Q&A. That's all from me. I'll just hand you straight over to Dindo. Thanks very much.
Thank you very much, Clive, and thanks everyone from joining. So my name is Dindo. I'm Chief Data Scientist at Yewno. We're based here in California. And I'm going to talk about why knowledge graphs are important for scholarly publishing. I have been working for 15 years in research and development and in academia, actually, prior to joining Yewno. So really the question and the problems that are affecting publishing world are pretty close to my heart. So I'm going to actually in this 20-25 minutes presentation go into the details of what we are doing here at Yewno and how we're actually helping and enabling publishing industry to achieve their goals in a better way, but on the other side also helping researchers getting their results and getting what they need in a more efficient way. So the presentation today will be around the following topics. So of course, we're going to delve into a little bit of what is really a knowledge graph. So what defines a knowledge graph? How can we make the best use of a knowledge graph? And then we're going to see a few examples of how knowledge graph is used in practice, and actually how we're using knowledge graphs here at Yewno. And then we're going to go a little bit deeper around the technology that enables the creation of our knowledge graph. And we're going to talk about concepts and disambiguation and dynamic environments. And this is actually what really distinguishes the knowledge graph technology that we're developing here at Yewno versus more traditional search-based platforms that you might be familiar with. We're going then to also show some examples around this idea of how we can enable this conceptual search and how can we enable this knowledge graph-based search. And then we're going to deliver some final remarks around tips and suggestions to content owners of how to integrate eventually the knowledge graph technology into their workflows. And then, of course, as Clive said, we're going to have a few minutes for questions, and please feel free eventually also to email any additional questions, and we can reply offline. So what is the problem that we're trying to solve here? So of course you're in the publishing space. So it's really important that from the perspective of publishers and content owners, you of course want your content to stand out from the overwhelming volume of information available and to be found easy. So these days we have a huge amount of scholarly publications available, and there is just the usual problem of information overload is affecting your work. If you're a researcher on the other side, as I used to be, you really want to find information, or you want to extract knowledge from this overwhelming amounts of information in an easy and accessible way. So we have these two worlds that are in a sense conflicting, And the technology of knowledge graph actually is really enabling us, and we're going to see how, is really enabling us to solve both of these problems. So one side, to make sense of this huge amounts of information, and on the other side, for the researchers, really enable them to find what they're looking for in an easy and more accessible way. And we're going to see that the knowledge graph actually, in a nutshell, is a structure, is a conceptual structure that really connects different entities, different ideas that can be extracted from these texts and connected together to form this mesh that represents eventually the knowledge. So this is how we're going to tackle this problem, and this is how we're going to how Yewno is actually solving this problem through our knowledge graph. And at the end, it's really everything is about knowledge. So extracting knowledge from this from the data is the ultimate goal. And here is a very nice quote from Leonardo da Vinci. I used to live in Italy as well, and actually, when I was working in academia, I was in Italy. So this quote is really about knowledge. So the acquisition of knowledge is always of use to the intellect, because it does drive out useless things and retain the good. For nothing can be loved or hated unless it's first known. So this is really the ultimate goal. On one side, we have the data in its very crude form and information that can be extracted from that data. But turning this data and information into knowledge is what really we're striving to do, and what really knowledge graphs are meant to accomplish. So what is a knowledge graph? Unfortunately, there is not a single definition of a knowledge graph. So the literature in this respect is still fragmented. There is still, although the idea of knowledge graph is not a recent one, there has been a search in research and in academia to actually develop a proper framework for the knowledge graph. So there are a number of definitions, and there are a number of different views of what really a knowledge graph is or a knowledge graph is not. So it shouldn't be a surprise if you ever came across the idea of a knowledge graph that you couldn't find a single definition that might give you an explanation of what a knowledge graph really is. So we have our own, if you wish, definition of a knowledge graph that synthesizes the main ideas of what a knowledge graph is. So we really, a knowledge graph in our view is as I said before, is a structure that acquires and integrates information into a dynamic knowledge base and applies a reasoner to derive new knowledge. So knowledge graph is a graph in the first place. So the graph is a computational structure from the computer science perspective that connects different entities together. So in our graph, we will see that we're going to have concepts, and concepts might be whatever we want to actually talk about, or whatever we want to represent. So these can be, for example, places, companies, people, ideas, subjects in a study subject, and so on and so forth. Knowledge graph encodes semantics, and that's very important because we want to be able to disambiguate the knowledge that we're talking about, and then connect these disambiguation pieces of disambiguated pieces of knowledge together, and we will call these disambiguated pieces of knowledge concepts. Knowledge graph enables derivation of new knowledge through an inferential reasoning process, and that's, I think, the key point. The key point is that you're not using your knowledge graph just for the sake of pure representation of knowledge, but you're using your knowledge graph to infer something new. To infer something new means that you perform a search on your knowledge graph, that you perform a reasoning on top of your knowledge graph. So from existing pieces of knowledge, you might infer or deduce something that wasn't available in the first place. And then ultimately, knowledge graph really evolves with new data. So this dynamic aspect is really the key point of any representation, of any knowledge graph based representation, because we really want to incorporate any new knowledge that can become available, to incorporate this in an existing knowledge graph. So you can see this knowledge graph as a living organism that really expands and grows as new data and as new knowledge is acquired. So these are the four pillars that will define really a knowledge graph, and we're going to see in the next minutes how we actually develop all of these pillars in our knowledge graph. And of course, nothing could be really possible without application of more state-of-the-art technologies from the artificial intelligence and machine learning in particular, because on one side we have publications that we want, as we said at the beginning, make sense of. We want to extract knowledge out of it, we want to represent it, and we want to put it in a way that is easily accessible for users on one side. And as we said at the beginning, for the publishers, we want to extract the most important and relevant pieces of information, turn this into knowledge, and then make the relevant pieces of knowledge actually stand out and be more accessible. So how do we turn something that is in its nature completely unstructured as text that is contained in the publications that we want to process into something that is more structured, like a knowledge graph? Because think of a knowledge graph as a structured entity that really interconnects these concepts together. So we can see on the left side a flux or a stream of text publications that are coming through the central part, which is a machine learning based or AI based engine that would turn this unstructured data into something that is more structured. And this structure actually is our knowledge graph. And our knowledge graph at the end is really, if you wish, is a semantic space where different of these concepts, as we call them, different of these entities really live together. And they are represented in such a way topologically that semantically similar concepts are actually close together in this semantic space. So we can see on the right here a representation extraction of our knowledge graph, where you can see different nodes that represent concepts or entities. And here we can see Nietzsche, Hegel, Kant, Karl Marx, Aristotle. So this specific portion of our knowledge graph is centered around philosophy, for example. And we can see that, again, semantically similar concepts are connected together in this knowledge graph. And semantically similar concepts are also closed topologically in this knowledge graph semantic space. And all of this is achieved through application of modern AI technologies such as deep learning, so deep neural networks, the ability to actually then also automatically categorize and extract topics out of text, and different sets of machine learning algorithms that we implemented then for the problem of disambiguation that we're going to address in a couple of slides. So this is really how we turn this unstructured, this huge content set of unstructured data into something that is structured, into something that can be eventually accessed, and into something that can be searched, into something that can be represented even graphically as it's shown in this slide, and so on and so forth. That you can imagine the power of this representation. So you don't have to read hundreds of articles to understand that there might be a connection between, I'm just here making a very simplified example, of course, let's say between Aristotle and Nietzsche in a sense, but the knowledge graph will do this work for you. It will read the text, it will extract these entities, it will connect these entities together, and it will then give you the possibility to traverse these connections and understand why these connections are formed. And this also leads to some to serendipitous type of knowledge discovery, if you wish, because very often, and many of our clients are actually very one of the let's say one of the most common comments that we have is that it really enables the serendipitous search. So you can find connections that you didn't even think that they existed, and once you have everything in a graph, you can really start seeing beyond this obvious, let's say, connections that are beyond these obvious connections, so you can start seeing a full and the big picture. Excellent. So, how this translates then in a technical way. So, as we know, the world of publishing has been traversing different stages. So, on the left here, we can see how libraries use to represent and organize their metadata. So we would have certain codes that would represent topics or categories or subject headings of different publications, and then we would then use keywords to extract to represent the most important topics that are given in a given publication. Then, with the advent of natural language processing, all of these processes can have been automatized in a sense. So the ability that we can now use the keyword search to quickly access any document containing that specific keyword has definitely been a huge achievement, and it's definitely something that is being used as we speak, and it's still probably the mainstream search capability that is offered through various platforms. But what we're offering here, and what knowledge graph technology is offering, and something more, is a semantic-based search, and we will understand this in a bit, where instead of hunting for keywords, we're hunting for concepts, and concepts again have their have this inherent disambiguation that is embedded into them. So if we, let's say, if we were to use a keyword search, and if we were to search for Apple, any keyword search-based engine cannot distinguish between Apple the company and Apple the fruit. So we would just be typing in Apple, and we would be hoping to get back the results that are relevant to us. And if we want to have more precision in the results, we will be adding additional keywords. So, for example, Apple company or Apple fruit, which in a sense will increase the precision, but probably will decrease the recall, because then a lot of other documents that might not have these keywords together will not pop up in the search. So the idea that stays behind the concepts is that we really that represents Apple as a concept, Apple as a company as a concept, and Apple as a fruit as a concept, and we project them in the semantic space, as I said previously, where the semantics is preserved and the topology is actually reflecting the semantic similarity between these concepts. And by using this technology, we can understand from the context of a piece of text if we're talking about Apple the company or Apple the fruit. So when the user searches for Apple the fruit, he or she will be given results that are really relevant to the search, and that are not purely keyword based. So also the document that might not contain these keywords will appear, as you can see here on the right panel with the example of internment. So you can see here from this exactly coming from our system, the user was searching for the concept environment, and you can see that we deliver 2 snippets of text that are contained in 2 different documents that don't really have the keyword environment in them, but they're clearly semantically about environment. So this is really the power of this type of search, that we go beyond the pure keyword search and we go into the semantic search capability. Other things that you can do with that we can do with knowledge graphs are really and with this idea of concepts, because again the key fact here is that all of our concepts are interconnected. So you can see also how these interconnections and how the strength of these interconnections change over time. And this is another key aspect of using knowledge graph and dynamic knowledge graphs in publishing, because you can again have this ability to represent over time how knowledge is changing. And by knowledge, again, we can think of a knowledge as this huge mesh of interconnected concepts, and all of these interconnected concepts have a reason of why are they interconnected. So if we then roll these connections over time, we can see how different connections are changing and why, for example, certain concepts are connected in a stronger way compared to other concepts. And this video here is showing, for example, the concepts that might be connected to the idea of tariffs and trade wars. So this was a very specific example that we were making, and a scholar was researching around this very important topics and macroeconomic topics. And our knowledge graph would actually then deliver in real time the concepts or other connections that might be relevant to your research, and you can see how this changes over time. So for the sake of time, I'm going to go forward, and I really want to deliver this message that everything can be really seen as a knowledge graph at this point. So we can really think of this paradigm of representing knowledge as extremely powerful and extremely well suited for the publishing. I just wanted to stress again the importance of concepts, and I just wanted to discuss two important problems that come with a traditional keyword-based search, and these problems are exactly synonymy and polysemy. The synonymy is the fact that different words or terms might have the same meaning. So, for example, in this slide here, we can see that Brexit and United Kingdom withdrawal from the European Union are exactly two synonyms. So any human being would treat them as the synonyms, but computers unfortunately cannot have this deep understanding of synonymy unless we build this AI technology into that. And also the fact is that these synonyms and their meanings can change over time. So we need to have a system that is dynamic and that can really track all of these changes. So in our system, if you search for Brexit or you search for UK withdrawal from the European Union, you would get the same results, because both of these are actually linked to the concept that is the UK withdrawal from the European Union. On the other side, we also have another typical example where we have multiple names for a drug, for example. So ibuprofen is a very common drug here in the US, but in UK it's called Nurofen. So the fact that these are actually the same pretty much from the semantic perspective gives researchers or users of platforms like this the possibility to really increase the recall, as I was saying before, so increase the breadth of documents that can be retrieved as a result of a search. On the other side, we have the polysemy, and the polysemy is the problem that specific terms can have multiple meanings. So let's think of a term, depression. So if I were a researcher and I was looking at something that is related to depression, I might be researching many different aspects of depression. Depression can be seen as a geological phenomenon, or depression can be seen as a meteorological phenomenon, or depression can be seen as an economical phenomenon, or we might be looking into Great Depression or Long Depression, or a specific depression that happened, economical depression that happened in the 20s. But this is not the end. Depression can be, of course, a psychological term as well. Depression can be also a physiological term, and we can also be searching around major depressive disorder. So think about this very simple term. Depression might have, in this slide we see 9 different meanings, but actually there are many more behind the scenes. So if I was a researcher, I wanted to research depression in the meteorological area, meteorological sense, it's really hard for me then to instruct my search engine to give me back the results that I'm interested in, unless I implement this idea of a conceptual and semantic search, where the system behind the scenes will treat all of these disambiguation problems for me. And I'm just going to go quickly over some examples because we're running out of time. I'm just going to go quickly around some examples. Major providers are of technology in general are what are the results that they're delivering, and we can see that even major tools that we might use in our for build these systems are actually having problems in disambiguating these concepts. So we will be seeing that many major tools that you might use are not really giving you the breadth of concepts that Yewno can give you, because we have more than 5 million, actually 6 million different concepts that you might be searching for. And disambiguating and extracting these from text can be an overwhelming task. So here we can see that these tools from Microsoft, DBP is another tool that is used mostly in academic context, but then we can go back to Google and Amazon. The fact that they are not extracting concepts from there using these tools, but extracting only very, very primitive, permit me this word, primitive entities is fairly limiting for developing systems like this. While on the other side, our system, as soon as our system reads any portion of text, it will try to extract all the concepts that are possible to extract and match to our internal knowledge base. So for example, here you can see this piece of text where we can extract Apple, we can extract debt rating, we can extract Moody's or different companies, but we can also extract bond credit rating. And again, this bond credit rating is never mentioned in this text anywhere. You can just understand that this bond credit rating is semantically a good fit for this specific text. And our technology will also give you the scores or the importance of these concepts within any portion of text. So just to complete my presentation, and this is the last slide, so then we can go into a QA session. I would say that if you were to adopt a technology like this in your organization, what would be the key questions to ask? I hope that I deliver the message of the importance of using knowledge graphs for search. But if you were to adopt any solution, what would be the key questions to ask? So the key questions to ask would be really around dynamicity of your of the solution. So is your environment dynamic? So is your knowledge graph expected to change over time, or is it just a static representation of the knowledge? So what we deliver is, of course, a dynamic representation of knowledge, and as we read all of these documents, we actually update our knowledge graph pretty much in real time. On the other side, this is the technology that you're using to build a knowledge graph capable of disambiguating entities and disambiguating concepts. And does it provide definitions? Because one of the key aspects that we saw in our technology is that a concept then can be understood from at a human perspective by reading a definition. So, for example, in the slide with UK withdrawal from the European Union, we could see that we provide a definition of what really that concept is. So you can understand if that's really what you're looking for. The same goes for the depression and different concepts that are linked to this keyword of depression. So is the technology capable of disambiguating? And we saw that from the technical perspective, from the NLP, natural language processing, and machine learning perspective, that's not a trivial, it's not a trivial task. Can the technology understand the context? So understanding the context is extremely important and powerful, because the fact that we can disambiguate really comes from the context, and different connections in our knowledge graph can be formed with different strength based on the contextual information. Another key aspect is the technology capable of learning new concepts or learning new representations automatically, or it needs to be fed by a human or manual intervention. And at the end, is the technology really capable of creating the connections and extracting the inferences from these connections? So this is really all of these 5 questions, in my opinion, in our opinion as Yewno, are the key aspects to deliver a knowledge graph that is capable of responding to the key question that we pose to ourselves in this webinar. And this was my last slide, and thank you everyone for listening. I tried to squeeze this in half an hour, but go back to Clive for QA.
Harris, thank you so much for what is a fascinating subject, I think. It never ceases to amaze me how very, very central to content is the transformation of content using AI technologies, and how fundamentally challenging some of that can be, and what a long way in some ways we've come, but an awful big journey ahead as well. I think it's really, really interesting. I think you presented it in a really fascinating way. The disambiguation and stuff like that just fascinates me. Anyway, it's not about me. Thank you so much for the time. We are really close on time. We try and keep to a fairly tight 30 minutes. I have one question I'd just like to throw at you. If you could give a couple of examples of where publishers are actually applying knowledge graph technology. How can they do that? Have you got any examples that you could just share very quickly?
Absolutely, absolutely. Without making any specific names, but we
Sure.
of course integrate. We have our processes that we implemented with different publishers that are integrating their content into this into the knowledge graph. So we would be given different feed, or we would be given a stream or feed of content from a specific publisher. This feed would go throughout our technology that applies this conceptual representation of that knowledge, and will extract concepts and connect them together in a graph. And then this would be then delivered as a final in a final stage through a platform that enables users to actually search for a particular ideas or concepts or context or text from that particular from this particular publication. I think we have I have here also Ruth Pickering, who maybe might give a better overview of this of how this really is applied then at a practical level as well.
Yeah, our audience, Ruth has just joined us. Very excited that Ruth has joined us. Ruth is the CEO of Yewno, and I think founder as well. Ruth, do you want to join in?
Thank you very much, Clive. Yeah, so what I would add to what Harris has said is I think the capability of full text searching. So many content owners and publishers have this fantastic set of content, but it maybe goes back decades or even centuries in some cases. And if you look back at the techniques that were originally applied, such as applying BISAC codes and a very limited number of keywords, maybe 3 or 5, or if you're lucky, 8, then if you think about something like a book, your chances of finding something in chapter 7, paragraph 8 are basically non-existent. And I think the great thing about kind of like the AI technology that Harris has explained is that it will algorithmically read the entire document and not only extract all of those concepts, but also using the tools, it will make sure that a word that was used in 1970 that has now evolved and is different today, that content can still be found. So I think the value to the publishing world is huge in terms of being able to understand the content that they have and to surface that appropriately in all the use cases that a researcher might want to find it.
I think that's a really, really fundamentally very important use for this tech. And sometimes it's quite hard to find practical examples, but that's perfect, Ruth. Thank you very much. We have got one final question that I would like to ask maybe both of you. This is been fired by Victor Mireles. You have talked about linguistic relations like being a synonym, but can this type of search answer questions of the sort, what medicine helps with headache because it knows that paracetamol is used to treat headache? Does that make sense? Do we get that?
That's a very good question. Absolutely. So this goes into a field that is called question answering. And this technology, of course, can enable Q&A capabilities. So this fundamentally, every question answering system behind the scenes is powered by a knowledge graph. And this is exactly what is needed to deliver this kind of technology. So we, as a company, are not delivering this directly, but you can formulate your query in a way that it would extract exactly what are the connections between, let's say, headache and different other medicine, and then you would be guided to actually read snippets of text or paragraphs of text where these connections can be explained in a factual way. So although we're not delivering directly this Q&A question answering capability, but the knowledge graph technology as such can be used to, and is usually used to deliver question answering capability. But behind the scenes, we do represent these kind of relationships. So in our knowledge graph, you would have a relationship between paracetamol and headache. And if you click on the edge on our knowledge graph, if we were using our system and our platform, and if you were to click on the edge connecting these two concepts in our world, you would see all the documents that would explain that relation and in a factual way. So absolutely.
Thank you. Ruth, Harris, thank you very much for participating today. I think it's been really interesting. For everyone who's joined us, we use a system called ZeoTag, which means a completely transcribed and indexed video of this webinar will be available to all of you. We'll send that to you in the next day. All that remains for me, well, I'd just like to flag up that next week's Wednesday webinar at 4:30. We're looking at no-code open repository. So building an open source repository with little or no IT skills. And that's going to be presented by Jan Mai, who's the MD of My Science Work. So please do sign up for that 4:30 next Wednesday, British Summer Time. And that's just a wrap up. We've gone a little bit over time, but it was a really fascinating subject, very well presented. Thank you to Ruth and Harris again. And I'd like to, I hope we'll be doing a little bit more with Ruth and Harris in the coming months. So thank you very much for attending, and have a good rest of the day. Goodbye.
Thank you.